Section 16.1, Part 1. You may have gotten a little crystal growing tree like this when you were a kid and tried to grow little crystals. And that's what we're going to talk about today, crystallization. But one thing important to remember, that crystallization of the solid solute out of a solution is not the same thing as freezing. So those are two totally different things. So the first thing to talk about is what factors affect how fast a substance can dissolve. So if you think about tea, and if you like sweet tea, you want to dissolve the sugar into the tea to make a solution. So if you think about a sugar cube versus granulated sugar, the granulated sugar will dissolve faster. And it would also dissolve faster if you use the spoon to stir it, or you had hot tea. So it's important to remember when we're talking about how fast a substance will dissolve is independent of whether or not it will dissolve in the first place. It's the composition of the solvent and the solute. Remember we talked last chapter, like dissolves like, and that determines whether or not it will actually dissolve. But once we know that it will dissolve, there are three factors that affect how fast it will dissolve, and these are the three. And we'll talk about each of them in more detail. So the first one is agitation. That's stirring or shaking, something like that. The crystals will dissolve more quickly because if you think about the process of solvation, remember that happens only at the surface of the crystals. And the reason that agitation will speed things up is because you're bringing fresh solvent continuously to the surface of your solute. Again, to remember, this agitation affects only the rate at which it dissolves. It does not allow you to dissolve more, so it does not affect the amount of solute. If something does not dissolve, it is insoluble, it will remain undissolved no matter how much you stir or how vigorously you stir. The second factor that affects the rate of dissolving is temperature. And higher temperature will dissolve more quickly. This logically would make sense to us now that we understand about kinetic energy and temperature. Higher temperature, the kinetic energy of water molecules is higher, so the molecules are moving faster. So again, thinking about that process of solvation, more rapid moving molecules will increase the frequency of the collisions between the sugar and the water molecules. The third thing that affects the rate of solvation is particle size. So smaller particles in granulated sugar expose more surface area to the solvent, the water molecules. The more surface area is exposed, then the more of them can be dissolved at one time, so the rate of dissolving is faster. Because remember, the dissolving process only happens at the surface of whatever your solute is. Once we get our solvent dissolved in our solute and we get our solution, now let's talk about what happens. Here in this picture, you can see a crystal here and the dissolved particles in the solvent. So what happens is that particles continually are removed from the solid into the solution, but at the same time, some of those dissolved particles are attracted and moved back into the solid. And these two things occur at the same rate, so there is no overall change in the system. So some are being dissolved and some are crystallizing back out at equal rates. This kind of solution is considered a saturated solution. It contains the maximum amount of solute that a given quantity of solvent can contain. So, for example, this was sugar, then the sugar water is saturated because I could not dissolve any more sugar in this beaker. In a saturated solution, we have a situation that we call a dynamic equilibrium. This dynamic equilibrium reflects the fact that some of the solute is being dissolved and some is crystallizing back out at equal rates. We can talk about the amount of solute that will dissolve in a certain amount of solvent, and we use the term solubility to describe that. We do have to specify temperature because the solubility is affected by temperature and pressure as well, particularly with gases. Solubility is usually expressed in grams of solute per 100 grams of solvent. So, for example, 100 grams per 100 grams of water. Gases have solubilities usually more expressed in grams per liter rather than as the other way with solids. A solution that contains less solute than a saturated solution would, we call that an unsaturated solution. In an unsaturated solution, we could add additional solute, and it will dissolve until we reach the point of saturation. When we're talking about liquids mixing together to make a solution, we use a little different words rather than soluble or insoluble. That's typically a solid dissolving in a liquid. When we're talking about two liquids dissolving in each other, we use the term miscible. So if they are miscible, if they dissolve each other in all proportions. So water and ethanol are soluble in each other, so we can dissolve them in each other as much as we want. Liquids that do not mix and are insoluble in each other, we use the term immiscible. So immiscible means they do not mix, and oil and water are examples of immiscible liquids. And that's the end for today.